A sample of the length in inches for newborns is given below. Assume that lengths are normally distributed. Find the 95% confidence interval of the mean length. Alright, so I have a set of lengths, and I want to find a 95% confidence interval for the mean length. Okay, so we want a confidence interval for the mean. So that tells me in the calculator I have two functions that I would work with, z-interval versus t-interval. Z-interval is based off of normal distributions, and in order to use it you need to know the value of the population standard deviation. That's not provided to us in this problem. So that means we're going to work with t-interval. Now t-interval, we can use the sample standard deviation. And that's not explicitly given, but we do have the data values. So we can calculate a sample standard deviation from those data values. So what we're going to do is this. We're going to take our data and put it into a list. So I'm going to hit Stat and go into the list editor and just start entering my data into this list. Okay, now the next thing that I'm going to do, I could go into OneVerstats and calculate the mean and standard deviation that way, but there's a nice feature in the t-interval function. So if you hit Stat and just go straight into t-interval, you can either set your data to come from the statistics of a set of sample data, or input the data and allow it to do all the calculations for you. So that's what we're going to do here. So we just need to tell it where our data is. So it's in L1. All we need to provide is the level of confidence that we're using. And when we calculate, we come up with the endpoints of our interval. And it's said to use 4 decimals here. It doesn't really provide that many in the problem, so we'll just give what we can. So 17.529. And 20.931. It actually would be a little bit more reasonable to just use a single decimal place because all the data is accurate to just a single decimal. Maybe even 2, but this is the best we can do with the calculator's output. Now, if you did want to get the 4 decimal places of accuracy, then here's a nice way of being able to do that without having to do any more work here. If you hit the vars key, so this is all the variables within the calculator, and everything the calculator does is stored here somewhere. We just did some statistics. So if you go to the statistics variables, press enter, and over to test, because we just did one of the hypothesis tests and the confidence intervals are contained in the same. Now if you scroll down, come along in the end of the list to 2 values, lower and upper. And these are the lower bounds and the upper bounds of a confidence interval. So if you get the values of those, so let me grab the other one. Then you have the same values but a little bit more accuracy so that you could round to 4 decimals. So 17.5288 and 20.9312 in this case.